Hello everybody, and get ready for some more contest fun because we're going to be doing another contest video. Specifically, in this video we're going to be looking at question number 2 from the 2004 Friar contest put out by the University of Waterloo. So we did question 1 in the last video. How about we just take a look at question number 2 right now. It's another 3-part question. So, the Friar Foundation is giving out 4 types of prizes, valued at $5, $25, $125, and $625. So before I even read the rest of the question, alarm bells are going off. 5, 25, 125, 625, these are all multiples of 5. Not only that, they're all powers of 5. 5 is 5. 25 is 5 times 5. 125 is 5 times 5 times 5. And 625, and this is the one you might not be as familiar with, is 5 times 5 times 5 times 5. So 5 to the 1, 5 to the 2, 5 to the power of 3, and 5 to the 4. Alright, so having noticed that, and hopefully that'll be useful, let's take a look at the actual question. A part. The foundation gives out at least one of each type of prize. So the $5 prize, the $25, one of each of these will be given out. If 5 prizes are given out, with a total value of 905, how many of each type of prize is given out? Explain how you got your answer. Okay. Well, there's 4 different types of prizes. So if 5 prizes are given out, and we know that at least one of each type of prize is given out, that leaves only one other type of prize. So let's take a look. And we know the total value is going to be 905. So we're asked to sort of justify or explain how we got our answer. So one of each type of prize. So that covers 4 of the 5 prizes. But how much prize money is that already? Because that'll help us determine what the 5th prize must be. So 5. Okay, we can get our calculators out, or we can try and do this in our head, or we can work it out on a separate sheet of paper. So 5 plus 25, that's 30, plus 125, that's 155, plus 625, that should be 780. So the 5th prize must be worth, well, the 5th prize has to make up the difference. So we know the total amount of prize money given out is 905, and we know 780 is already accounted for just because one of each type is given out. And you can check it out with a calculator. You can probably work it out. It's got to be one of 525, 125, or 625. It's really only could be 125. So I think the question asked us to detail how many of each type of prize were given out. It's got to be one. It's got to total up to 5. So 1 plus 2 plus 1 plus 1, that's 5. So 5 prizes definitely, and there's at least one of each type. And we can do a double check on our calculator. We get 905 when we add all these up. So that was part A. Yeah. All right. how many of each type of prize is given out, and we explained how we got our answer. We mentioned that one of the 4 of the prizes are already accounted for, and that totals up to $780. And so the remaining prize had to be $125. That's nice. Okay. So B part. If the foundation gives out at least one of each type of prize, okay, so again we're accounting for $780 and 5 prizes in total. Alright. So just like the last question where we had a value of 905, determine the other 3 possible total values it can give out. Explain how you got your answer. Alright, so now we're just asking for the other possible combinations. So in part A, we saw that if you have the 5th prize, it's $125, you get a total of $905. So we have 3 other choices for the 5th prize. That's $5, $25, or $625. So the $5 case, so we have 2 5s, 25, 125, and 625. So we can add these, or we can just know that these last 4 are going to be add up to 780. And we just add on 5. $785. So the $25 case, well, the total is 5 plus 25 plus 25 plus 125 plus 625, or really that's going to be 780 plus 25. And that's going to be 805. So the last possible situation is when the 5th prize is another $625 prize. So if that's awarded, we get a total of 5 plus 25 plus 125 plus 625, and then another 625. These first 4, 5, 25, 125, and 625, that's 780. And we can add a 625 to that and work that out either by hand or by calculator. And we get 1405. And since it's a written question, we're going to give a nice little therefore statement. $785, that's one of the possible totals. 805, and finally 1405. So those are the other potential possibilities if we have only 5 prizes and we still have to give out one of each kind. Okay. So on to C part. Just double check that we got everything in B, one of each prize, 5 prizes in total, the other 3 possible total values you can give, and we justified our answer. We explained that the 5th prize has to be 525 or 625. Alright, so C part. There are 2 ways in which the foundation could give away prizes totaling $880, while making sure to give away at least 1 and at most 6 of each prize. Okay, so we're still going to have a 5, a 25, 125, 625. We're still going to have $780 accounted for. And we'll explain that. Determine the two ways of doing this and explain how you got your answer. Okay. So, we still have $780 accounted for. We just need to explain why we have that. And then that'll leave us with $100 So since each prize amount must be awarded at least once, we still have $780 of the total money accounted for. So what's left over? Well, we're trying to get a total of 880. We know that 780 has to already be there. So we're going to have $100 left over. And we need to make up this $100 using 5s, 25s, 125s, 625s. But we can have no more than 5 of each of them. Because, remember, as the question said, at most 6 of each prize. Well, we have 1 of each prize already accounted for. That makes up the 780. So to make up the 100 that's left over, we can use at most 5 of each prize. Alright, so we can't have more than 5 5s, for example. We can't have more than 5 125s. That's okay. So notice that we can't use 125 or 625. We're trying to make up a total of $100 in prize money. $125, $625, these are too much. So we have to make it up using 25s and 5s. Okay. Well, how can we make up $100 using $5 and $25? We could have 4 of the 25s. Remember, 4 times 25 is 100. 25 plus 25 plus 25 plus 25 is 100. And we can have none of the 5s. It works out exactly. So instead of 4 of the 25s, we could have 3 of the 25s. Right, we'll take away a single 25, and that means we'll have to make up the difference with 5 of the $5 prizes. So we'd have 2 of the $25 prizes. That would account for $50. And we'd have to make up $50 out of $5 bills. But I don't know if they're actually coming out in $5 bills, but $5 prizes. We'd have exactly 1 of these 25s, and that means we'll have to have 15 $5 bills. And lastly, we could be using no $25 prizes and have 20 $5 prizes. But only the first 2 use no more than 5 of each type. Notice here that, for example, the fourth one, $100 is 1 $25 prize and 15 $5 prizes. We're using way too many $5 prizes. If we did this, we'd have 6 $25 prizes, one $25, 2 $25, and 16 $5 prizes. That goes against the original question. Okay. Remember, right here, we can only use at most 6 of each prize. Okay? So that means it's got to be making up this $100 using 5 25s or 3 25s and 5 5s. So I'll make a little statement of that fact. So how can we do that? Well, we could have exactly one 6 25, one 1 25. We could have 1 plus 4, which is 5 25s, and 1 5. And we could double check that on our calculator. 6 25 plus 1 25 plus 5 times 25 plus 5 is 880. Or the other way is with 1 6 $25 prize, 1 1 $25 prize. And those don't change. But then we can only have 1 plus 3 of the $25 prizes. That's 4 $25 prizes in total. And lastly, 6 $5 prizes. Okay. And in this way, we've used 1 of each type of prize. We haven't used more than 6, and we have the 2 ways, and we know exactly why there are only going to be 2 ways. We showed that on the last 2 pages. So that concludes question number 2 on the 2004 Fryer. If you liked that question or you liked the way I handled it, throw a like down on the video or leave a nice little comment. But other than that, I'll see you guys in the next video for question number 3. Ta-ta!